Yes. ZKGM, everyone, another Union Hall cast. Welcome potentially all the new yappers joining us. I'm gonna disappoint you and say like this is basically a chat we do to talk about engineering, tech, cool stuff with partners. So there's not gonna be alpha being dropped here or other BD related things. Instead, I'm here with Shiv and Dean. Shiv from Boundless, who just launched their beta mainnet as well, and Dean, who works also on the cross-chain interop space and then more on the orchestration side. So I think we'll be diving deep into some of the apps and products that are being built on all of the cool infrastructure we've been investing in over the last couple of years. Shiv, maybe you want to kick us off and do a brief intro?
Yeah, so hi everyone, I'm Shiv. I'm the CEO of Boundless. Boundless is the universal ZK protocol that came out of RISC-0. RISC-0, of course, being the world's first ZK VM. We're a Seattle-based company, though we have quite a lot of folks in New York. The reason I say this is because I know Agoric is also kind of East Side based, and it's not often that like we all get to hang out together. Prior to RISC-0 and Boundless, I helped manage engineering at Ava Labs, the company behind the Avalanche L1, and I also worked at Coinbase, where I managed a bunch of engineering orgs, onboarding, compliance, country launches, lots of interesting nightmarish projects. And before that is my Web 2 history, if you want to call it that. Microsoft, Amazon. Everyone lives in Seattle has to work at Amazon and Microsoft at some point.
No, I just worked at Microsoft.
Actually, we overlapped. I was I don't want to say how junior I was. I don't want to age you here, but we did overlap because I did look at your LinkedIn. Yeah, and Lyft and Grab as well, which is a Southeast Asian rideshare company. As an engineer, most of my experience is in database systems, and as an engineering leader, mostly in market design. So rideshare markets for exchanging goods, services, and so on. So that's really my background. Have a degree in computer science, of course, but also a degree in economics.
Very cool. We had one front-end engineer who lived in Seattle, and I think he's like maybe the only one that didn't work at Microsoft, but then lived 100 meters from their campus. So every night he would be on a call with us and walking his dog throughout the campus, showing us like, this is where that team is. This is where that team is. Here, I get free coffee.
Yeah. I mean, Microsoft campus is beautiful. Just a shout out to everybody. This is the best time to visit Seattle. Come visit us.
Yes.
These
are the 2 months that it looks amazing.
Yeah. Dean, give us a run through as well.
So I'm CEO at Agoric, and we have, since the beginning, since we started, our technology has been how do you build large-scale asynchronous systems in blockchain? The all these other systems, starting from EVM and on forward, you're writing programs that start and end within a single block, and then you're trying to build larger scale human systems out of that, and no human use case starts and ends within a single block. And so as we want to break out of just swaps or just relatively simple interactions, that's something that needs to be solved, that needs to be easy, because that's where as you start to get more and more sophisticated interactions across different chains, that's essential. And so what we observed is that the world is moving to where users want to be able to use stuff in Web3, but they don't care about the tribes, they don't care about the tech stack, and so forth. My analogy is, when I order a hamburger, I don't care whether the restaurant is Amazon or Google. I just want my hamburger, and on an app. And so it's the same way with blockchain, where and Web3 solutions in general, is that we want to be able to deliver solutions to users that they may not even be aware as to whether they're Web3 or Web2 or not. And to the extent that they are, they don't care which platform. They just want it to be the high integrity and decentral, and the safety properties that Web3 should be able to give them, and be able to do the kinds of economic things that it's supposed to enable from anywhere in the world, without interference from random busybodies. And so that's what our tech stack does. And that ability, we have shifted from focusing on tech stack and focusing on the platform, which is frankly far enough along, to something that lots of people phrased as build the first 5 apps yourself, right? So we shifted over in May to build an app, and build an app that takes advantage of our technology because that lets us do things that other people can't do. And so it is, we are working on an app that will be out to closed beta beginning of Q4, where it's it can deploy and manage your assets across chains, across ecosystems. I've got, money in Aave. I would like one click to have it pulled out of Aave and put into Compound. And the fact that one's on Arbitrum and one's on Base, I don't care. Just make it happen, right? I want to be able to pull that out and get into the latest cool thing that's happening over on Solana. Not because I know about Solana or have a Solana wallet, but because I heard about this thing, I saw something cool that people were doing and I wanted in. There's plenty of those where I'm a travel site and I got loyalty points and it works across different chains. Users don't care. They just want to travel and get rewards that they can spend in various places. Again, the user story, you don't want to have stores joining a loyalty program based on which chain they happen to, favor that week. And so that ability to build out seamless cross-chain interaction is the thing that's excited me for a long time. So, talking about background, I started early days working on distributed systems technology, secure distributed operating systems, actor systems, concurrent logic programming systems. If people are familiar with promises in JavaScript, I apologize. That came from our work out of Xerox PARC back some time ago. I then, worked and did secure email and secure systems. Was one of the early cypherpunks working on, early crypto systems and crypto mixers, on out through building. I worked on the first production smart contract in the I won't tell you when, and then we had a smart contract platform project at Sun Microsystems Laboratories to do smart contracts, running on systems to control all of the network capabilities, as networks were just starting to go from 10 megabits to 100 megabits. And so being able to pay to get, video over the network was a valuable thing, right? And then my last gig before Agoric was a multi-billion-dollar payment instrument where we were taking checks, paper checks, which were still, 20 billion paper checks for $30 trillion, right? And making them so that they could be electronic and still be legally checks. And so that was a multi-billion-dollar payment instrument before going into Agoric. So nice. Mostly distributed system stuff in one form.
Amazing background, Dean, and amazing energy as always. I think for today, like the first big overlap I see, besides like going to cross-chain stuff and such, which we'll go into a bit too, but Dean, you've discussed that so often to me as well. First overlap I kind of see is like you both have a lot of experience on building VMs actually, right? Because with Zero originally, the first ZK VM, Dean, I think Agoric is technically also a completely custom VM, right? That's what you guys originally set out to build.
Yep.
So I feel like there's like the first like hardcore engineering overlap. I've regrettably never built a production VM myself, although I feel like for an engineer, that's always sort of a rite of passage, or at least the thing where you think I will indeed build like the perfect programming language and then start working on it till you build a terrible programming language. Chip, maybe on this, because I know our community like often asks, like, does Union work with Boundless? What's the difference for those who are less technical clients? Yes, we work with Boundless and with Zero. We've been talking for years and basically share tech updates. We're looking to integrate Boundless ourselves with Union, both the signal and the proving market, but also a little bit like what are the differences? Like what really is a ZK VM? Why is it so powerful? What do you guys do with it?
Yeah, I mean, there's actually a fantastic story here. I think even Dean will appreciate it because it's the arc is very Seattle-ish, in that like it's always hardcore and you start in like a place of like curiosity and start building something out. The story actually goes with one of our co-founders, Jeremy Brustel, who was a security engineer, and he had just sort of like got to a point where he sold his previous startup to Intel. And he was like, oh, I'm looking for my next big idea. Jeremy famously never went to college and taught himself enough mathematics and computer science to basically advance the field himself. And he's reading Eli's paper on ZK and, his application in blockchain. And he goes to his friends who are all like security hackers, and they're like, yo, guys, this is the future. ZK is the future, like, and it's going to be amazing. And this is what it does. They're like, okay, cool. How do we ZK? Like, what am I supposed to do? And they're like, oh yeah, you need to write circuits. They're like, yeah, that's not a thing. I'm not going 20 years back in my learning journey. I did that in college, and like nobody's writing circuits. So he went back and famously, apparently, sat in his bathtub thinking about this problem, and sort of realized what he needed to do to get his friends interested in ZK was to make it accessible to them with a high-level programming language. And essentially build a VM. His background in hardware, compilers, mathematics all came into play. I always feel like he was born for that moment. It's like, all his experiences led to him thinking about how to actually make ZK accessible. And that's what the ZK VM is, where you actually provide a program as an input to the circuit and creates this custom circuit for you that represents the program, you can take inputs and so on. That's a paradigm shift, because prior to that, for 30 years before that, ZK, or verifiable computation as the larger field is known, was the domain of universities. 300 people writing circuits, 200 people auditing them, small little $500 million industry that they just kept it to themselves. It really sort of opened the doors for anybody who could write or learn how to write Rust to participate. That's great. Now, the interesting question that comes after this is, usually when you abstract something to a higher level, you lose out on something. There's always a trade-off, right? All of engineering is trade-offs. What is the trade-off here? Is it perf? Because the biggest concern with ZK for the longest time has been, it's not performant enough. It's 100,000 times slower than regular computation. Did you make it even slower? Now, the genius of VMs, and I do think people should research it, especially if you are a computer engineer and striving to become a better engineer and look into things like database systems, operating systems, and so on, is that they're platformized, they're stacks, they're always layered, and there's a reason for that, because it allows you to attack the stack at different levels and start optimizing. If you have a really good boundary definition, you can now have people go into the hardware level, the platform level, the engineering level, the mathematics level, and so on, and keep improving that. And that's what we started doing. So over a period of 1.5 years, and I'm not talking about the last year, the year prior, 1.5 years prior to that, we already started surpassing handwritten circuits in performance. The most famous, or I personally think it's, as far as I know, it's the most expensive circuit is Polygon's ZK EVM circuit, where they spent hundreds of millions of dollars acqui-hiring every ZK researcher on planet Earth, put them all in the same building and said, build this one circuit, and they did. Recently, they stopped investing in it because there is no way that it's going to beat out the ZK VMs anymore. ZK VMs,
what?
Beat out ZK VMs.
Okay.
Handwritten circuits, simply because we're optimized for GPUs, we go faster, we are cheaper, easier to run, easier to maintain. It's just become well-known fact now that this is how you deliver ZK. So much so that 1.5 years ago, there was just one ZK VM, us. A few months later, 2, and now there's 40. So it's basically now this is how you deliver ZK has become sort of the mantra. Now, the interesting thing is, because we use open source standards, RISC-V, Rust, and all the other things as well, all the ZK VMs have started looking the same as well, which is great for us, because that takes us to the next step in our journey, which is how do you package and deliver ZK VMs, right? You don't just sell the engine, you sell the car. And the car is, how do I get ZK delivered on chain? How do I ask for proofs? How do I pay for proofs? Is it decentralized? Is it permissionless? Is it censorship resistant? Is it like AWS? Is it a SaaS service? People have all of these questions. And then Boundless is actually the answer to that, where we wanted to build a network, which sort of like Chainlink, how Chainlink gives out oracles to every chain. We wanted to provide ZK to every chain. So that's really what it allows us to do. The main thing is we also wanted to unleash the power of tokens in markets. The underlying innovation of tokenization and Web3 is that it allows for open markets. It's important, if you want to drive down costs, to harness the power of markets. And that's what we want to do. Again, to make that even better, we didn't just build a marketplace for ZK, we built a ZK marketplace. And what I mean by that is the marketplace is aware of the thing that is being sold and bought. And we wanted to build a primitive to help innovate on the market itself. So we call it proof of verifiable work. So any sort of proof generated on Boundless using RISC-0 has cryptographic metadata associated with every proof, basically cycle counts. We can actually, at the end of an epoch, tally up how much work everybody in the market has done and give out emission rewards in a very, very fair way. Okay, Dean has done 10 cycles, Carol's done 5 cycles, I've done 1 cycle. Dean gets 10 times as many rewards as me and twice as many rewards as Carol. We are able to do this, and this is actually a very elegant innovation of proof of work. So
in that scenario, are they solving other people's problems, or they're just solving their own? I mean,
so you can do both things, right? But to be honest, there is so much surplus demand already on mainnet beta that they are doing everyone else's work. But there are going to be periods of time when like you just want to like fill your GPU. You have excess supply for whatever reason. You could give yourself a job as well. Now, the interesting thing is we didn't want people to just solve like random puzzles and problems. The Signal is actually a fantastic experiment which has played out so well for us. Signal is full consensus proofs on Ethereum. We're the first team to do it, where a light client, for example, for your viewers who may not be aware, a light client kind of samples nodes. So Ethereum has, I don't know, a million nodes or whatever. They sample like 200 nodes and go, this feels like this is the consensus. Is there any economic security? No. Do you get slashed if you're wrong? No. So it is a very low bar for security. Some teams actually depend on it. They probably shouldn't. But full consensus proofs are just hard. You need to prove consensus of all the nodes. It takes like quite a lot of computation. Proof sizes are massive. Firstly, building the client itself requires deep knowledge of the Ethereum client and how it works. And also, like, there is no one team that was ever going to do it because it'll end up being a public good. We were in a unique position to facilitate this. So that's what we did. We built the client. We are running it live on mainnet beta. The name is intentional because testnet is.
Can it keep up with blocks being produced? Like, do you produce a consensus proof for every Ethereum block that's being produced, or do you guys do a periodic one? Because I saw some of the provers in the market. I wasn't aware how to interpret the numbers. They take like 4 hours or something.
We are ramping up. Basically, we're ramping up. So like, it's, by the way, it's only been like 7 days, right? So we are ramping up and we want to get to a point. I'm sorry?
No. Go ahead.
No, we've been ramping up, and over a period of time, we want to like prove all the blocks and then also prove other chains as well. This especially has a lot of like value add for teams like Agoric and Union that are working in the interop space because it gives you access to verified consent, verified state of Ethereum on other blockchains, helps you deliver more complex products, right? Like Dean was talking about people wanting hamburgers. They might want fries. They might want ketchup. This is how you help deliver that. Make your products a lot better, right?
Yeah, I have a couple of ZK questions, but go ahead. Go ahead, Josh.
So with like the current compute capacity, like how many of these full consensus proofs do you guys produce per day? How many do you see come along?
I think it's a few ourselves, but we like pump out requests like I think by the hour or so on. We do a couple of those proofs. We've actually had other people not associated with Boundless or Resido also do the proofs, so which is fantastic for us. We want to keep ramping that up. I think there was a second question there. I forgot.
Yeah, because I was indeed wondering, like, if I do like a request right now for my union relay or for a full consensus proof, how long does it take before like I get one to finish a bridge transaction? I know
so you can actually like price the bid based on that. As an example, like when you actually request a proof on Boundless, what you say is, I want this proof and I want it by this time period, and this is how much I'm willing to pay for it. So obviously, if you want it much faster, you're asking someone to run use a lot more machines. So you get priced accordingly. If someone says, "Oh, I'm willing to wait a while," then you sort of like adjust the price. In rideshare, you would say like like make it quick or make it cheap. It's always those two axes. For some folks, like proofs are much more urgent, and you can price your bid accordingly. There's also like, I'm personally very, very excited by just one thing that I've been seeing for the past 7 or 8 days on the market, which is because it is an open marketplace and innovation is allowed, unlike say an Uber or a Lyft, where the innovation has to come from the Uber team and the Lyft team, the rate of innovation is insane. I've never seen this ever in my life. I've designed 4 or 5 markets before me. I've never seen the community come in and be like, I'm going to bot this. I'm going to MEV this. I know this bid is going to fail. I'm going to wait for this bid to fail, and I already have the proof done. People are doing very, very, very interesting things to optimize the market, and that just blows my mind. I wish everybody could be as excited as I am about how Web3 actually really turbocharges markets, because once you realize that power, there are more products to be built to harness that. I do believe a lot of companies do understand that, but like I just feel the general engineering population doesn't really like see it that way. They focus on their problem. The deployment, the harnessing of public markets to actually turbocharge the product, growth hack without spending billions of dollars. It's a unique opportunity.
I found this very interesting too. We originally in Union, or still have, by the way, this is our relayer design, that they kind of race against each other. So we had built in a mechanism to basically push relayers to improve, right? Like if you have access to specific proving hardware, etc., then you're gonna make more money, outcompete parties. But we don't have the ability for like provers to contribute equally to a proof or like a certain number of cycles. So you have to run this on like private hardware at the moment. So I'm really keen to see if indeed like we have Boundless produced proofs. I think what we're going to see is that first, indeed, like all these Boundless provers were very happily like collaborate on generating union proofs, right, and take a share of the fees. Oh, thank you, camera. I think I shook my hands too much. Let me
I
say
love the AI on the camera. Like,
yeah, exactly. This makes me very happy.
This help?
we all zoom in.
Yeah, I have no idea how I actually like make it zoom out again. So I'm gonna be zoomed in, or actually go a little bit backwards like that to fix it.
I
away
knew
from
what
my
you were
desk.
saying was important. Yes.
Yeah, what I want to say is, I think in the end, the provers are like really collaborate with each other very happily, and then we're going to see indeed like this private MEV start to take place, right? Where you kind of know like the public markets are going to be slow, or they're going to fail on this proof. I can maybe leverage some of their work and then hop on that. So I'm very keen to see this whole market play out over time.
I mean, that's great
What
for
is-
consumers and builders. Go ahead, Dean.
Right. What is the proof work that Union does? What is it? How does it currently verify ETH transactions? And what is the proof work that it provides now that ZK?
Yeah, so Shiv was relentlessly dissing our light clients, but I have to disagree. By the way, like light clients are not randomly sampling. Like actually corrupting like the ETH light client would take like a couple of billions of capital to coordinate that. So it is a bit more difficult to do so. But definitely like full consensus verification much better, right? Like that is full consensus plus execution would be the golden standard, right? Like you could not do better than that. I think right now we still see as well with our own circuits that it still kind of outcompetes, not anymore on speed, because you guys are like able to parallelize your proving. So on speed, you guys can basically just dial up all the way to the top and do the same. But on cost, we're still kind of more efficient on this. But we saw big improvements because the Risk Zero team added the like big number mathematics precompiles for us specifically. So with that, we see it come a lot closer. So we're actually now at the stage with Union where we're contemplating, do we write like Risk Zero precompiles ourselves for the work that we're doing, almost like try to have a precompile kind of for the light client work, or at least for some steps into it to like have a really efficient, and then we can just lift off of your prover markets, because fundamentally we built Union not to build a ZK proving market. That wasn't really the goal. So we love actually stealing all of the work from you guys and just lifting off your success. But yeah, so that's what we do, Dean. Like we take like blocks from validators, basically do a signature aggregation, generate a ZKP of that. We kind of want to extend it a little bit more, see if we can do cooler stuff. So some of the stuff we've been contemplating since Union has like an aggregated state root, so basically contains all state roots of all chains, is see can we do like private bridge transfers. That's like a really big thing that I think is going to become way more important. For last year, there was about 700 million in bridge MEV that like solvers managed to take, or parties like observing bridge transfers. And I think it's going to grow quite significantly. So I think the need for like private bridging is going to become quite a lot bigger. Maybe not private for indefinitely. So when you're listening to this, don't think that it's going to be like Tornado Cash, but just private for the duration of the transfer, so that like you're not going to get front run by anyone. And for that, you really need like ZK, but ZK Lite clients plus more, right? You're going to need to add some special sauce to it as well. Maybe keep the execution private, something like that. So that's still an unsolved problem. Only like ZK protocols can really attack this. So if you look at like current protocols like Across or Layer 0, those are not really geared to solve these problems, since like the relayer and all of the parties outside, they don't aggregate a state root, they don't create like a final proof where you don't know what the inputs are anymore. And for me at least, like this is the final frontier for interop. So we're very keen to work on that. I think definitely like Risk Zero is going to be a bit of our magic sauce and Boundless to solve this.
Yeah, I mean, like one thing I'll say is like there's something my BD teams and constantly keeps telling me, and I agree with them as well, that the Union team is the sort of canary in the you fixed it. Canary in the coal mine in a lot of ways, like always advancing the field. and asking more from us, which I think is the way to go as well. Privacy for sure, right? Like once you get that, this is where I actually think like a lot of innovation on Boundless is actually going to stem from, which is trying to solve problems for our ecosystem partners. Because you solve a bunch of problems for a bunch of product suites, and there's just like this compounding effect of like, hey, like, Union needs this building block, let's go build that. And then like, a bunch of other people use that as well. And this sort of ability for Boundless to build these public goods, or these modules that are like composable and usable in like different scenarios for different kinds of folks, is going to be why Boundless succeeds. But also we're going to build a whole ecosystem of partners who are all succeeding in their own way, building on top of each other's success. So we're really looking forward to that future, where we have like different offerings for everybody, and everybody realizes what they can do with ZK and sort of like supercharge their applications.
Yeah, this is something that we were looking to integrate using Boundless as well. And one thing we observed is like, for let's say the financial app that you guys are building, Dean, it's like not only do you need like interop and bridging, you kind of need like Oracle data, both from like the destination chain, like what's the price data, sometimes off chain, like ZK TLS. I think is a really good candidate for this. Still, you see like Redstone, it works really well, but it's not that decentralized. Chainlink is not that decentralized and really expensive. So actually, like for building these like really complex cross-chain apps, you always run into this issue, like how do you even get the data to know did something succeed on the other side, or before I make a request, like what should the pricing data be that we put in this? Of course, you can provide it from the front end, but I feel like ZK has a solution here too.
Well, and a lot of what you'd like there is, I mean, a lot of these data, there is a Merkle proof that is the result of the computation, that it's on, I should be able to ask one machine, efficiently get a Merkle proof that I know chains up to the roots. So I know that the data that's coming in is just quality. I shouldn't need an Oracle to tell me a user's balance on another chain. I should be able to get a proof, and I just verify it. That is surprisingly hard right now. And so you end up relying on some, essentially Oracle structure, multiple independent parties that are reporting the same value, and they can say, yep, that balance changed as of transaction 42. We all agree, and that the new number is this. Great, I've got consensus of my oracles. But if just one of them presented me the Merkle proof and I could efficiently verify that, that would be just strictly better. And so that's one of those things which that doesn't need zero knowledge. Modulo, how do you aggregate it efficiently? How do I,
you get a thing where some like smart contracts do like a transformation of a value themselves. So you realize that like indeed you have like the storage try, so you can figure out like what's the balance someone stores, but the Uniswap contract might do like a transformation, and you don't really want to re-implement that logic, right? Like you want to call like the solidity getter for it ideally, so that like code doesn't go out of sync, etc. And for that, you kind of do need a bit of ZK, because you would really like to do like simulate running the smart contract, executing it on that block to see what would the value then be. That's like the nicest, but that's still, I want to say like it's only a year or two away. I'm not sure. Like ZK has been going really fast, but
but a year or two away from when?
Exactly, it's a year or two away, but not for. I do want to say like shit, like indeed, like there's a Merkle root somewhere or Merkle tree somewhere that has this. That feels like a slogan almost for the work we do. I've spent way too many nights looking through other chains' code bases, thinking there must be a Merkle root somewhere that has this, right? Must be.
And they just don't. I like the idea of doing this because one of the problems is you can query the chain by running the getter, and having 100 machines all do the same simple get code and come to agreement about the answer, which you then have to, right? That's crazy, right? And so, yeah, you end up running it off chain, and if you could have someone produce a proof of that, that'd be great. Now, the other general thing that I'm curious about the evolution of zero knowledge stuff, from YouTube. Back to, remember a thing I said where, people write programs that start and end within a block. And so we build surprisingly powerful things out of that kind of tech. But most of the zero knowledge stuff that I've seen is the same way, right? I've got it's in some sense pure functional. Here's my starting data, compute a new state, with a proof that I did the computation, blah, blah, blah. It does not really support something that has long-lived state. And so the question of how do you build up, how do you use that? I can't have a zero knowledge that I run on my machine and present a proof that this happened, for an AMM, because everyone else who wants to trade on the AMM has got to get to the same state in order to compute the update. And then we have to share the update in a zero knowledge way and that sort of thing. And so an AMM mostly doesn't make sense in a zero knowledge context, right? It would make sense if, okay, I'm running the AMM, you present all your bids to me, I will run an algorithm, decide who got what, and present you a proof that I ran the algorithm, and you don't know anything about what anyone else did, but I saw all the data and I kept it as state. And if I go offline, you're all out of luck, right? And so it's and so now you've got the zero knowledge thing that can solve a very nice piece there, but you remain with the who's got the actual state and how replicated is that, and how do you know that they don't run away with it, and and that sort of thing. So I'm curious where that fits.
Honest, like this is like what you're describing is feels like a topic for like 2 years ago, like sequencing and data availability, right? Because this is kind of indeed like you kind of need to have the data so that someone else can resume generating proofs, right? And like let's say like in your system, the original like prover has all the data. Everyone can verify, so you can never commit fraud. But obviously, if he just disappears and you lose the data associated with the state root, then no one can ever resume generating proofs, right? So you're kind of in a bricked state. So, but I think it's still really hard, or at least like just a lot of engineering efforts to have a system where indeed like users only like do a bit of proving themselves. Someone aggregates this again. You get like a quite coherent state. I think Penumbra does some fancy stuff for this under the hood, but that's not only ZK, that's like really fancy systems design almost, right? But how these things interplay, which data is necessary for the leader and the verifiers versus which one is necessary for just the user. I'm not sure if it's like, to be completely honest, if those systems are that wanted by users at the moment. I think like a system where the prover has information, but you kind of trust the prover up to a certain point, and you just use it for scalability. That I feel seems to gain most traction. Like Union uses ZK, but to be honest, we don't care about the zero knowledge portion of it. We care about the succinctness, like putting big computation into small proof. So for us, like everyone can know all the inputs up to when we do the private bridging. That's when we indeed like need to think where we store the data. Big problem with private bridging is, does that mean that like only the user knows, or does the relayer also need to know? And that's kind of where it gets complex, right? It's like, do you share the bridge info with the relayer itself, or can you do it in such a way that you're not even sharing that? And that becomes quite complex overall.
Yeah. Plus one to the the topic of like what do people actually want, and what do we deliver, right? I think in a lot of ways, like people do get very I think the theoretical maximum is like everything is built on chain. It has all the properties of the best chain, and nothing ever goes down. But then you simply can't build expressive applications. Then people get disappointed. But then you find where the people are willing to like trade off, to be honest, especially like when it comes to like trading and whatnot. They're actually comfortable. And Coinbase is like a walking, talking example of this. Like people are just comfortable giving over, having that sort of censorship resistance to some extent, and being like, hey, but I do want to make sure you're not cheating me. Like when it comes to money, the thing that people more often care about is like, I don't want to lose my money and I don't want to get cheated. And if you can prove one of the others, like people actually get satisfied. It's about sort of like incremental value to some extent as well. There is, I think, maybe time when like it becomes more important for us to be able to handle this much state within the ZKVM, have like pause and restart on ZKVMs, or like use that functionality to break that up. And I believe that's what Penumbra does. I'm not 100% sure. Also, Penumbra, another, I think, Seattle-based company. So it once it becomes more important, I think we start focusing on that to a large extent. Like for now, I think the biggest issue with like ZK is making it fast, cheap, and available. Like solving the DevX problem, because I don't know if you've seen this, and it's quite a disappointing number. There's only like 7,500 full-time devs in Web3, according to A16Z. That is something we need to improve first before we sort of like try and tackle, what more can we do, because there aren't enough people to do it at the moment. And I do believe like once we start actually opening things up, as an example, what I really appreciate what Dean said, which is like, hey, we're focusing on building applications right now. To be honest, that's what we're doing as well. And when I talk to other infra companies who've been around for a long time, they acknowledge that that is a mistake that they made. They didn't like spend enough time building applications and understanding and dogfooding their own shit. I know a lot of like absolutely world-class developers who know everything about the Ethereum client, but don't know how to write a smart contract or haven't written one. Their assumption is I can figure it out. Yes, but you must try deploying in production, and then you'll realize, holy shit, that was so annoying.
Yes.
And it's something that larger companies,
You
private
make me feel bad.
right. Like
It
larger
was the
companies,
thing you have to do, and we took too long to do it. Yeah.
yeah. I mean, this is what like Microsoft, Google, these companies are able to force their employees to do because they're like, no, please dog food. Today is dog food day. You must dog food today, and they go do it, and then come back and they're like, yeah, that didn't build. The documentation is horrible. I couldn't figure out how to find anything. This took me way too long. People figure out these issues and they go and fix them. I think it's very important for everybody to dog food. I think the easy way out is for me to say, oh, Union's a fantastic partner. They'll give me feedback. It's like, yeah, but Union's got its own problems to deal with. They have a day-to-day job. Their job is not to give me feedback. It's great that they do, and they do so often, but I shouldn't depend on that. I should be building applications myself. I am curious, Dean, if you want to like sort of talk a little bit about how you actually made that pivot into like, yeah, let's build 5 applications. Why is that important to you? And how are you going to sort of like incorporate that in your sort of plan or business plan or whatever?
So originally we were, JavaScript platform. And so you could just say, you want to build smart contracts in JavaScript, you could do it here. But we did have layers of tooling and abstraction in order to try to accomplish key goals like early intent stuff where, it's not you send money to a random number and hope something good happens. It's you say, I will give you this if you give me that. And the system enforced it. And so it was different. And so it took some time for people to get up to speed and so forth. And, you try and do DevRels and some works and some doesn't. But so last year, 2024, we helped drive the chain abstraction narrative. Us, Frontier Labs, Near, a few Clear, et cetera. It really drove chain abstraction. And it got traction. And our unique thing was the orchestration. That observation that as Web3 moves towards users want to be able to use it, but they don't care about your tribes, which is like, coming from a large scale distributed system and a cross chain kind of viewpoint. That was always how we thought, right? And always how we built. And so, so our ability to program that stuff where you could write a simple smart contract that is like, reach out over to that chain over there and unbond my position and await that, right? People are familiar with JavaScript await, which by the way, came from a project that we did at Microsoft. But you wait that, 7 days later when it's unbonded now, move it over that particular bridge because it's cheapest today to another system, buy something, stake it, that process looking like, something that a human could understand instead of the, huge complex state machines that people were otherwise having to program. That seemed very powerful for doing those kind of end-to-end user use cases directly, where users don't start and end within a block. As I said, they really, I want to start from there and buy that thing over there, and if it takes 20 minutes, that's fine. I want to authorize it now, and you go figure it out. And so we were explaining that to people, teaching them that, but it's one of those things where, vivid examples are so much more powerful, right? And so, I would show examples of here's what you ought to be able to do, but, I know that's the core of the guts, and the work around it is bigger than that and harder than that. And so it's one of those things where explaining that difference of how being able to do this cross-chain coordination, this orchestration on-chain is higher integrity, right? It gives you the integrity of replicated execution of smart contracts for stuff that involves activity on multiple chains. And that's something that, pretty much no one else can do. But explaining that difference, explaining that power, there's sort of a, oh yeah, show me, right? And it's like, oh yeah, it's going to be a lot easier for us to use that power because we understand it than it is to explain it. And, we were getting traction. People were starting to build, the platform is there, people can build on it. And they were successful. We were getting more traction with orchestration than we ever had with the JavaScript smart contract platform. But it was still a long go to market. I mean, we could still see, okay, Ellis built some cool stuff. Omniplex built some cool stuff, and still are. But, They then have to roll out, then they have to succeed, then they have to go, then they have to drive enough volume. Whereas if we could, and we can only help market that so much. We built Fast USDC, but it's a back-end service. We can't really market it directly to users, right? And it does cool stuff, continually moving money every day, but it just would need to be in major through lanes of dollars for it to be able to move the needle on usage and revenue. And so getting to where we can actually directly market to end users with stuff that is uniquely powered by orchestration is really exciting, right? It is the thing that will move the needle. And also then it'll be obvious, oh, okay, this can do stuff that I can't do otherwise, or that's weird and awkward otherwise. And so it then becomes, now we've dogfooded, now we've encountered all the problems that other people were going to encounter before they did. Or maybe after a few of them did and explained things that were hard. And that's just going to be a much better place for people to start.
Yeah, we went through, I wouldn't say similar journey with Union, because in the end, like Union is not like a full app L1 or like as encompassing as like a VM itself, right? It's like we had like an idea, like this is what the product does. This is where like the money comes from. User will pay for this service specifically. But initially we like thought, okay, we're going to have our own UI, and then probably we'll see people build like their own UIs on top, more like Stripe, right? Like integrate directly with the app. That's still, to be honest, like quite a big focus. But we realized that we had to just spend more engineering efforts on our own app. Our very first version, just to showcase what's going on under the hood, I still love it so much. Like but the design is actually terrible for like the masses. So if you ever see screenshots come along from like a Union v0, that it's like I don't know, the Curve UI. We were inspired by that, so we went like Windows 98 with it design-wise. But we now expanded to even doing our own Oro BTC derivative, because I think it's indeed important, besides having like an app and making a developer see what can you build with this, perhaps having some additional like financial engine running, right? Like you see this with Hyperliquid working really well, because like the perps do so well, there's so much capital coming in that indeed, like if you build your app very close to that, you get close to the capital. I think of course like Luna in the end like went down, right, and USDC depacked, but the reason builders chose to build on Luna was for proximity to UST, right? Like there was partially like a good driver why some developers get excited. So as by Dean, like with you, what you guys are doing, quite excited by it, because the like kind of vault approach here indeed provides potential builders with ways to have a product that optimizes that, right? So if you guys manage to get a billion of TVL capital spread over 10 chains into this, and a builder looks at it and says, I can build a product that gets 5% more APY, I'm going to take 1% of that myself, and I just build this on top of what you guys have built, like that's the perfect marriage.
Now, to be clear, we're building an app to be a successful app. So it will illustrate orchestration by succeeding, and that will, and indeed, one of the things is there's also a major change we have to do to our tokenomics, in order to have the value of build and the tokenomics accrue from orchestration. And we know we need to do that. We've got designs for that, but for the team and for me, that really is secondary to let's get the app going. The tokenomics don't matter if the app doesn't matter, right? And at least initially. And so my focus is really it's 100% in, narrow down, and build the app. Build an app that will delight people, that will do things that they otherwise can't do, and do them nicely. It's sort of this seamless access across blockchains, where I know that us and Union have to talk more about being able to integrate and use that, but that ability to seamlessly access Web3 stuff, both initially from a user point of view, so people can see it and touch it and feel it, but also you then have a service point of view, right? You have the ability, as you say, for people to add programs that would access this and be able to use that seamless plumbing to control assets and move them around among chains. We've got it, tied into MCP so that AI can talk about it, can help you, can provide, can provide prioritization and recommendation and that sort of thing. And so that functionality is about make an app that looks like it has traction in a market that matters, that solves a problem that people really want, in a way that happens to be unique. We have a moat because of orchestration, and then we can fill in and have it tie into all the infrastructure and value stack that makes that possible. And so that's all happening in the background of getting that tokenomics tuned up. But the focus is all about how do you make an app people will love.
Yeah, I think it makes so much sense as well. Like we went through this bit of a phase where I think everyone thought like one big VM will win, right? Like Solana is taking so much share, but now
never
with
thought that.
obviously the two most
That
hyped
was
things that
always gone.
it won't scale, of course, but also we see like indeed like stablecoin specific chains doing extremely well, right? Two most hyped assets for me, indeed like Bitcoin and stables at the moment, and we actually see like purpose built chains being built for that. So once again, the thesis of actually it's going to be 1,000 chains, and when this new market, like when BlackRock or the next big bank is going to do their own stable, etc., they're probably going to do their own chain again to make their ecosystem. So actually, if you want to give your users access to the best yield, right, without them needing to figure out, oh God, there's 1,000 different stables out there with slightly different yield profiles, then indeed, like bridging, orchestration is all very fundamental. And I mean, for you guys, Boundless, that just means you need to 1,000x your GPU capacity, right? This just puts in so much more need for provers to come into this market.
I mean, 1,000x seems very, very possible. Like in 1 week we went 10x. So just 7 more weeks, I guess. But
so you're gonna get big enough that you're gonna be arguing with AI houses to get the GPUs.
I mean, if I'm doing that, like I definitely have like a better mic setup, and like I'll have AI on my camera. Like I start investing in some gear. But it is quite interesting when you say that for Boundless and ZK. This is where like it gets into the OpEx business of like the back end, and this maybe like it's not that engineering heavy, but it is worth understanding. Is that ZK is not able to use like the best in class machines that AI needs, the power hungry monsters, because we can't like fully utilize it. We just can't. We can't max them out. We don't get the best cost to like performance ratio. We are just one generation below, which is great because AI loves moving up the food chain and leaves this like collection of machines that have been used for like a year and have like 4 years left in them, and we can just like take them on. So we are very happy to ride this coattail. Another interesting sort of perspective on this is like, I think I was reading Balaji on Twitter. He tweets quite a lot, so one of his tweets where he talks about how blockchain and ZK are the shield against AI, the sword, because even AI cannot change information on Ethereum. Like it can't do that. So there is a sort of like a sword and shield setup there, which I really, really like. That we are setting up for that, and I really do think there's quite a lot of like overlap in the growth curves of both of these industries. So like that's great. The last thing about the 1,000 chain thing, 100% agree. I actually think there has to be custom. People talk about it in chains, but I think that's too specific. Custom consensus domains is what the phrase I prefer. Is like for people who are building certain application, chains make sense. Sometimes it's like, oh, it's just like I'm going to run a database and that's about it. And like people just have to get used to it, because I do think as people become more focused on customers and what people want from their applications, their need to conform to what a blockchain is and what a blockchain should be and what the blockchain wars are and the conversation on crypto Twitter will become less relevant as they start focusing on customers a lot more. We as like sort of like infrastructure providers or people on top of whom you'll actually build the application are going to end up being much more focused on them rather than on the chains and what the chains prefer the world look like. Right, like the world is going to look the way it wants to look. Like there's not a lot we can do about that. We need to make sure we sort of adapt to that and slowly, iteratively take people towards sort of like a goal where it's cost, UX, and it's compliant in every way for them to use, such that we also provide censorship resistance and decentralization and things of that nature. I think the conversation around like will people just flip a switch is probably not true. Nobody flips a switch in transforming their stack. They move in like slow iterations. It's going to be a long haul on that, and we just need to be a little bit patient, I guess.
Exactly. Guys, you've elucidated me so much. I'm very pleased to be with such industry titans. I don't want to take any more of your time, so maybe each take a final 30 seconds, 1 minute to show the best part of your project, like the final message that you want to share with our community. Thanking you for not actually relentlessly shilling your own projects, but giving some of like the real like engineering deets on what works, what doesn't work. But feel free to shill now and give a final message.
Dean, do you want to go first? Or?
No, go ahead, Shiv.
Okay. For us, like it's a exciting week. We are 1 week into mainnet beta, and just not the order of months, but a few weeks maybe away from like a mainnet, or we don't want to wait like 20 weeks for mainnet. You can catch up on everything that we do on Twitter, of course, but also encourage you to go to the explorer.beboundless.xyz. Take a look at the project. Take a look at the orders coming in. We have over 800 provers online already, representing thousands of machines doing proofs. Most of the proofs are coming in at $0, which is fantastic news for everybody who wants proofs done. We hope to continue that energy. So yeah, and also hit me up on Twitter or whatever if you have questions. Happy to answer. Thank you, Carol, for having us.
Thanks so much.
Yes, certainly. Thank you, Carol, for having us. So, as I said, our focus is primarily on the WiMAX product, which is the seamless, coordination of assets for yield maximization and yield management. We're very excited about that. We got, we're working with UI designers to make slick UI. We'll be heading to, we'll be doing some UI testing with users in the next, 2-3-ish weeks. Heading towards a closed beta beginning of Q4, and just really excited about that. I think it's a big deal. It will show, it'll be useful. It'll show the power of the platform, and it's sort of the start of being able to do lots of things that we can do by having smart programs running with high integrity on blockchains, coordinating assets and activity across multiple chains. We are, that drives a shift in our tokenomics, which we're working on, and that will address some gaps that in the to make the build token relevant, but so they're sort of get the chain working, get it focused on delivering and supporting applications rather than being a broad platform for lots and lots of things. Let's just make sure it can execute on the key applications and then ship some applications that are just that people want. So that's our focus. We're happy for people who have hung in there. We're happy for people who provide us a lot of discovery information on product. And so we're generally building in public, talking about every week what have we done now. We've got an alpha version of the contract up on mainnet that we'll be starting to test in the next couple of days. And we'll be gradually iterating with live live stuff on mainnet that we can play with and start to scale and then, as I said, end of Q3, beginning of Q4, get other people into. So very excited about what's happening for the next 6 months at Agoric, and I look forward to showing people what we can do.
Awesome. Well, once again, thank you guys so much. Everyone listening in, thank you so much again. We'll see you next week again. ZK Jim, and have a nice end of your week.
Thank you.
ZK Jim.
Cheers, guys.
Thanks, Carl.